Welcome to Komatsu's Resource Tips series on easy ways to right-size equipment for your job. Please note all content in this presentation is copyright protected. We believe your success is our success. That's why we want to support your business and operations during these uncertain times and beyond. Please check out more resource tips on our website. In this presentation, we want you to understand the benefits of right-sizing your equipment, know what to look for when working through the right-sizing process, and what tools Komatsu offers to help and assist throughout the process. Now, we are pleased to introduce Craig McGinnis from Komatsu's Business Solutions Group.
In addition to providing some practical business tips, we want the Resource Center series to help you get to know us, the Komatsu employees working behind the scenes who help make sure you get the most out of our equipment. I studied metallurgy and materials engineering at Illinois Tech. After graduating, I started my career at U.S. Steel in Gary, Indiana. I worked there for about 4 years before joining Komatsu as a marketing engineer, handling special bucket sizes and other projects. After a couple of years in that role, I was able to make the jump to product marketing and focused on rubber tire products, primarily wheel loaders. Finally, in early 2019, I had the opportunity to move over to the Business Solutions Group, or BSG as we called it. Now, let's jump right into right-sizing equipment, the real reason why you're watching this tip series episode. I should start with a quick definition. What do I mean when I say right-sizing? Simply put, it's choosing the right number of right-sized machines for your job. First and foremost, the equipment you rent, lease, or purchase needs to be capable of performing the work you need it to do. The machine's size, weight, and dimensions are key to ensuring it will be able to execute the job. As we'll see later, some tasks inherently call for tracked machines, while others can only be done effectively with wheeled machines. But just because a machine can perform a task doesn't mean it's the best choice for the task. It may sound obvious, but bigger machines are going to be more costly than smaller ones. There's more steel in the frames, making them heavier. The engines produce more horsepower and therefore consume more fuel, and the tracks and tires cost more to replace. Remember to keep machine depreciation in the back of your mind as well. Some fleets also have excess machines, and if the engines are running, you know there's an operator in the cab. Dropping a truck or eliminating backup units is a simple right-sizing strategy. We all want to eliminate waste and improve efficiencies in order to be more competitive and profitable. Thinking through and implementing the right-sizing steps we're about to cover gives you the chance to improve your business's margins. We have a 7-step right-sizing process that fits just about any earth-moving or material handling application. You might notice the earlier steps consider larger macro factors, while the later steps get into the details. The steps work best when done in order, so resist the temptation to skip ahead. I'll drill down into each of these individually. First, you want to visualize or identify your application. To do so, ask questions like where's the job site and what material is being moved. Consider things such as working conditions and how long you have to complete the job. This is important to gain a good overall understanding of the work. Next, make sure you explore how far the material must be moved. Are we talking a few hundred feet or a few miles? This is important because the type and size of equipment, the right-sized fleet, will depend heavily on that distance. Then, consider your loading area. What are the ground conditions? Will you be digging below ground level or into a stockpile? Since virtually all downstream processes depend on the loading tool, it's especially important to determine the right size machine for the loading area. Now, consider the haulage tool and look at alternatives. How will you get material from point A to point B? Again, distance is important, but so are road conditions, clearances, and obstacles. Longer distances often call for larger trucks, but smaller loaders might not be able to load the bigger trucks. At this point, you probably have a few ideas that are likely to work. By applying the Goldilocks principle, you might be able to identify some fleets as too large, others as too small, and hopefully select one that is just right. To break a tie, or to really sharpen your right-sizing pencil, compare the total cost of ownership of the remaining fleets. There could be good reasons to utilize and implement larger equipment, but don't be surprised by the additional expense. Once you've settled on and mobilized your right-sized fleet, it's important to manage and evaluate it. Komatsu's telematics system, Comtrax, enables our customers to monitor key pieces of information such as utilization, working modes, fuel consumption, and payloads. This knowledge can help managers stay on top of their fleet. Now let's drill down into each of those steps a bit more. Like I said, step 1 has us visualizing your application and operation. You probably know it like the back of your hand, but it never hurts to revisit things with a fresh set of eyes. You'll find this step especially handy if you are discussing your project with another person who is not familiar with it. Things you take for granted might not be well understood by others. Start with the material. Are you handling blasted limestone or granite, clay or sand, or even timber? Maybe the job site is a scrapyard, a landfill, or a farm. The size, shape, and density of material will eventually play an important role in your right-sizing decision. How are the ground conditions at your job site? Are you working on hard, flat pavement or rutted mud with no roadway? This piece of information can help make the determination between rigid frame dump trucks, articulated dump trucks, or even a tracked product. Next, how big is your work area? Are we talking the size of a city lot, an entire subdivision, or maybe even hundreds of acres? It can also be important to note unusual environmental conditions, such as extreme elevations, temperatures, or the restricted visibility that sometimes comes with underground operations. Turning to the operation itself, chances are you have a deadline. The project must be done by a certain day. Or maybe you have a production target, usually a certain number of tons or cubic yards you need to move every hour or week or month that must be achieved. This is an essential factor when right-sizing fleet for your operation. Also, think through whether the operation is very repetitive, with the machines doing the same thing over and over. Or if it's more variable, where one machine might be called upon to do many different tasks. Sports cars are fun to drive and great for going fast, but they're not the best for picking up some 2x4s and then getting the kids from soccer practice. Finally, think about the operation schedule. One way to complete a big job with smaller machines is to run more hours, maybe like a second shift every day. But when that's impossible due to zoning and labor restrictions, bigger equipment might be required. Now that we have thought through the project at the highest level, let's get a little more specific. How far do you need to move your material? Track machines are inherently slower than wheeled machines. You're rarely going to see a bulldozer going more than a couple miles an hour, so they're typically a bad choice if you need to move material further than a few hundred feet. Think about that slow, unproductive, undercarriage-eating reversing time if you used a bulldozer to push long distances. This is the main reason why longer distance hauls call for wheeled machines. They are capable of higher speed continuous travel, so they are able to get material from point A to point B much faster. A bulldozer pushing or spreading is probably working on its own, doing its own thing independently. The same can be said for a wheel loader in a load and carry application. Wheel loaders do well in load and carry applications for distances less than about 1,000 feet. Around that point, or even less, you should consider letting the loader focus on digging and bring in trucks to handle the hauling portion of the operation. This allows both machines, the wheel loader and the trucks, to do what they do best. In any case, something will need to load the haul trucks, usually a wheel loader or an excavator. When using haul trucks, it's relatively straightforward to maintain fleet production when haul distances increase. You just add trucks to the fleet. Next, let's look closely at the loading area, starting specifically with the ground conditions. This will dictate whether you must run a track machine or can use a wheel loader. Very poor floor conditions call for track machines because they have lower ground pressure and can navigate the rougher environments. If you're working on a paved or compacted surface and can maintain decent conditions, you probably want to take advantage of the maneuverability and speed of a wheeled machine. Either way, the loading area should be set up to take advantage of gravity-assisted bucket filling. This means the bench, stockpile, or face is high enough that when the machine raises and curls its bucket, material will naturally fall into it, improving bucket fill. Typically, this means a bench should be at least twice as high as the bucket. When working in a stockpile, observe the material's angle of repose and understand how the material will settle when digging. Avoiding undercutting when working on a bench also helps prevent slides. Not all job sites offer the flexibility of reconfiguring the loading area. Sometimes you are just stuck with what you've got, so it's important to play to the natural strengths of different machines. For stockpiles and faces that are dug at ground level, a wheel loader will probably be your best bet. If you're up on top of a stockpile or bench and need to dig below grade, then an excavator will do a better job. Only the excavator can take advantage of loading trucks from above. Cycle times can be substantially faster if the trucks are positioned below the excavator. Then, they don't need to raise the bucket as high to clear the truck body before going back for their next bucket load. The last thing to keep in mind when it comes to your loading area is that most downstream processes are dependent on what the loader provides. A loading tool has a maximum upper limit of production, known as the loader-dependent production rate. Any other factors, such as when the loading tool is waiting for trucks, because the trucks are slowed down to cross an intersection or must wait at the dump site, reduces the productivity of the loading tool. Planning for those reductions or losses is critical. This can mean running slightly larger machines than theoretically required, or running multiple smaller machines that, when added together, will meet your production target. With the loading concerns addressed, let's take a look at hauling or moving the material. Again, underfoot conditions are the first things we should consider. It can be tempting to run a higher capacity rigid frame dump trucks and move more material with every truckload. But that's not a real possibility unless you can guarantee those trucks are going to be running on firm, well-maintained roads. Otherwise, you'll need the all-wheel drive capabilities of an articulated dump truck. Making sure the trucks are dimensionally compatible with the loader is critical for efficient operations. Ideally, an excavator would load the trucks from above, so truck body height is not a concern. However, wheel loaders approach the trucks from the side, so they need to be able to clear the dump truck body. Reach is also important with both excavators and wheel loaders. Reach means that the loading tool should be able to dump into the center of the truck's body for maximum fill and stability of the payload. Remember too that the more buckets it takes to fill a truck, the fewer trucks that can be loaded per hour. Ideally, wheel loaders will fill trucks in 3 to 5 passes, and excavators fill trucks in 5 to 7 passes. The basic idea of running larger trucks is that the same production can be achieved with fewer machines. This is especially important on very long hauls. If a truck cycle time takes, say, 30 minutes, you only get 2 cycles per hour. This means it's a good idea to move as much material as possible during each of those 2 cycles. Otherwise, a large number of trucks would be needed to achieve the production target. Conversely, if a truck cycle time is only 5 minutes, you can get in a dozen round trips per hour. This means you probably don't need to run more than a few trucks to stay on target. We all know that machines need operators, so thinking carefully about the production target, cycle time, and underfoot conditions can help determine if smaller, versatile articulated trucks or a few larger rigid frame trucks are needed. If we did steps 1 through 4 correctly, we should now have a few fleet options that are capable of doing our job. You might have identified 3 bulldozer sizes capable of achieving your production target. Or you could have narrowed your choice between a wheel loader paired with several smaller articulated trucks versus a couple larger rigid frame trucks. Maybe you know you'll be bottom level loading rigid frame dump trucks with an excavator but aren't sure whether you need 4 or 5 trucks. This is actually a good place to be. We want to have options to choose between. Only with options can we compare and say something is better or worse fit for our job. Developing 3 options is best, but even 2 will challenge your assumptions about bucket sizes, cycle times, and job efficiency. It will also help avoid simply mobilizing the same fleet you have used in the past or taking someone else's word that they know what's best. Put another way, challenging assumptions and developing options helps break out of the "this is the way it's always been done" mentality. So how do we break a tie? What if we can't decide? First, to break a tie between multiple fleets, it's a good idea to reconfirm that each fleet will get the job done. Can the loader really clear that dump truck body? Is production estimate too close to the target, potentially putting ourselves at risk of missing our production target or deadline? Assuming your fleet options can in fact do the job, the best tiebreaker is total cost of ownership, or TCO. TCO can include many things, and different companies may use different factors in their calculations. Some of the most common elements are machine pricing, fuel and depth consumption, maintenance and repair, parts and labor, and consumables like undercarriage, tires, ground engagement tools, and other wear parts. If the smaller fleet can get the job done just as well as the larger fleet, but at a lower total cost of ownership, you know you've just right-sized the fleet for your project. Looking at the owning and operating costs should always be a part of any fleet decision, if only to budget accordingly. Today, Komatsu offers Care Plus programs, which allow you to lock in maintenance and repair costs for most ownership periods. Following these steps, you've mobilized the most efficient fleet for your job, but we're not quite done yet. Our last step completes the process, and without it, it is possible all of our hard work could go to waste. Today, telematics, specifically Komatsu's contract system, provides many critical data points which help manage your fleets once they are in the field. Of course, telematics provides the location of your machine, but it can also tell you much more. For example, using contracts, you know how much fuel a unit is consuming and whether the operators are doing productive work or letting it sit idle. Activating features such as Komatsu's auto idle shutdown can support residual values by extending the time between maintenance and reduced wasted fuel. Newer generations of Komatsu machines can also provide information on productivity and suggest whether operators could be running more efficiently. These features, along with other comprehensive fleet management data, quick and easy online parts ordering, and improved data access, are available via Komatsu's new My Komatsu page. Head over to mykomatsu.komatsu to get started. I know we've covered a lot in the last few minutes. The right-sizing process involves aspects of optimum fleet recommendation, visualizing total cost of ownership, and telematics-based insights. BSG specializes in each of these services and is standing by to help apply them to your job. I want you to know that my team is here to help discuss any of this information in more detail. Thank you for joining me today for these tips about right-sizing your fleet for your job.